Fantastic. Okay. Look at the title of the notes. This entire chapter is about significance tests. We are testing a claim, those hypotheses. We have to find enough evidence or not for the alternative hypothesis. Now, today, just like last time, is specifically about population proportions, meaning this: you will have a P in your hypotheses. The next time I see you, the very last lesson of the year, 9.5, is going to be styled just like this, but instead of proportions, it will be about means. So instead of a P, you'll have a mu in your hypotheses, but we'll get to that next time. So we're going to do what's called a four-step process. All that means is we are putting together everything we've learned thus far into one big giant problem, and the very first step of the four-step process is to state. There are four things that you need to put in the state section. You will need to state your hypotheses. So you today will be writing the null and alternative hypotheses. You will need to tell me what your variable represents. So when you write the P, you'll have to tell me what it represents. If that doesn't make sense to you yet, that's fine. You'll need to just copy the significance down right out of significance level down right out of the paragraph. Remember, that's alpha. You'll just need to tell me what alpha is in the state section. And then, this is what I'm going to stress a lot, is showing me that we have some evidence for the alternative, and then we'll proceed to finding convincing evidence. So there will be some evidence based on the sample. That's all of that just in the state part. Then you're going to plan, which I think is going to be, for most of you, it's going to be the easiest part of the four-step process. All you're going to do in the plan part is you're going to check that the conditions have been met. If you have already forgotten what those conditions are, look at this handy dandy little box right here. You'll need to make sure that the random sample condition is met, the 10% condition, and the large counts condition. These are the little formulas that we plug into for large counts, and we make sure that they are greater than or equal to 10. You won't have a test. Remember, it's just going to be the project. So you can refer, you can use your notes on the quiz next time. So take good notes, okay? They will save you. So planning is just checking the conditions. You can probably fly through that pretty quickly once you've done it once or twice. And then you're going to actually, what you're doing in the plan is you're making sure that you're allowed to proceed with your significance test. If all of those are checked, then you can do. That's specifically three things. Those 3 bullet points are what I want in the do section. You're going to give the sample statistic, which today, since we're talking about proportions, is going to be the sample proportion, otherwise known as p-hat. You're going to tell me p-hat. You technically will have already found that right up here. I'll explain when we get there, but you won't have to sit and do anything for p-hat. You will have already found it in the first step. Then what you're going to do is calculate what we call the standardized test statistic, otherwise known as Z. You have to sit there, plug into this crazy looking formula like we did in the notes last time. Pretty much all of that will be given to you. You might just have to think a little bit, and then you'll put that in the calculator and get your Z value. From there, you're going to draw a little picture. You're going to show me that you understand what Z is and how it leads into finding the p-value. Everything boils down to the p-value. We're always, this process is working up to finding the p-value, because once you have that, then you can finally do step 4, which is conclude. You can finally draw a conclusion. You're going to compare the p-value to alpha, and that's where you're going to write either we do have convincing evidence or we don't have convincing evidence of the alternative hypothesis. Now, before we turn the page and practice this, look at all the goodies in this little box here. You've got your formula for Z. You've got a reminder of when you get to the step to find the p-value, you're going to use normal CDF in the calculator. Your lower and your upper are going to depend on the problem itself.
Teachers, please pardon this interruption. At this time, we're going to pass on the pledges and the moment of silence. I do apologize. I was in a meeting.
When you have used your calculator to calculate your p-value, your lower, your upper, okay, that's when you have your shaded region and you figure that out. Remember that if the p-value is less than the significance level, you are going to write a sentence on step 4, conclude. You're going to write convincing evidence for HA, and you're going to put that in context of the problem. Okay? If you find that your p-value is, and that really should just say greater than, it's not ever going to be equal to alpha. If the p-value is greater than alpha, then you are going to write your conclusion sentence saying that there's not convincing evidence for HA in context of the problem. Now, for now, I want you to skip over this type 1, type 2 error stuff because luckily that's not in the 4-step process. Okay? We're not going to worry about that today. But these 3 teeny tiny little pictures at the bottom are so very important. I'm going to zoom in and I'm going to explain something that will help you a lot. Okay? When you get to the part where you're finding the p-value and you have to make a decision which way to shade, it all goes back to your alternative hypothesis. If you used a greater than symbol in your alternative hypothesis that you wrote, so you better do it the right way, if you wrote the greater than symbol, then you're going to shade to the right. Now look at what that picture is telling you. You're going to shade to the right. The z value that you found in step 3, the do part, that's going to be your lower that you put into the calculator, and your upper is going to be the 1000. So write that teeny tiny on there. If you glance back at your alternative hypothesis and you used a less than symbol, then you're going to shade to the left. It's literally an arrow pointing to the left. Well, think about what that means. Look at that picture. Since you're shading to the left, the lower is going to be negative 1000, and your z value will actually be your upper in this case. So if you're ever confused when you get to the screen that asks for lower and upper, or if you're ever confused and you don't know which way to shade, look back up at your alternative hypothesis. The very last, we're only doing 3 examples today, and example 3 is going to be like this. We haven't looked at very many of these 2-sided hypotheses in our notes. That's when you have the, if you can't see it because it's really small, that's the not equals to symbol. Which means if you're reading along in the paragraph and it says something like, we want to know if it's different than blah, then you'll put the different than symbol. What you'll notice here is we don't just shade to the left or shade to the right, we shade in both tails. And so all you'll have to do, and I'll explain this better when we get there, is you will have to find the area in one tail and then just multiply by 2. That's the only extra step in this kind of problem, is once you find the area in one of the tails, once you find the p-value in one of the tails, you're just going to multiply it by 2 because these are the same, because this thing is symmetrical. That's it. That'll be example 3. Now let's turn the page. This is kind of what your quiz will be like. We've seen this problem before, so I'm just going to tell you the gist. You are a potato chip producer, and you get this truck of potatoes in. And if you find evidence that more than 8% of the potatoes in the shipment have blemishes, then you're going to send the truck back. I don't want to make potato chips out of a bunch of rotten potatoes. If you don't find evidence of that, then you're going to keep the truck, make your chips, okay? Now, I'm right here in the middle. The potato chip producer has just received a truck of potatoes, and a supervisor selects a random sample of 500 potatoes because he can't possibly look at all of them, so he selects 500. And it turns out 47 of those 500 potatoes have blemishes. Is there convincing evidence at the significance level, alpha equals 0.10, that more than 8% of the potatoes on this truck have blemishes? And all we have to go by is that little sample of 500 potatoes. So here's how you're going to tackle these. Let's look at the state part. the very first thing we're going to do is we're going to build our null and our alternative hypotheses. H sub 0, that's H null, and HA is your alternative. You'll list them in this order, and here's what we know. There's a percentage in the problem. Therefore, we're talking about a proportion. So P will be my parameter, population proportion. I also know as a student that there's always an equal sign in the null hypothesis. So I don't ever have to think about that. The percentage in the problem is 8%. That's our threshold of whether we're going to turn this truck away or keep it. So that 8% is what this whole entire problem is based around. So that's the number as a decimal, 0.08, that we are going to see in both of our hypotheses. That number will always be the same in each of the hypotheses. It'll never be different. So all we need is this symbol right here, and it's the most important thing because it's going to tell you how to shade later on. Well, this one's pretty obvious because it says a couple of times if more than 8%, more than 8%, in other words, greater than 8%, is there convincing evidence that more than 8% of the potatoes on this truck have blemishes. Now that's only part of the state process. The next thing you're going to need to do, since you just wrote a P in each of these, is you need to tell me what P stands for. What does it mean in this problem? It's the what? Yes, it's the proportion of the potatoes specifically in the entire truckload. That's the population, is this whole truckload of potatoes. So you're going to get some points for this one, and you're going to get some points for this one, and if you can do this right, you're going to get some points. I'm not going to check for spelling, grammar. I just want the gist. So if you do something like that's the proportion of potatoes on the truck or in the shipment that have blemishes, that's great. What you're really doing there is you're letting me know that you understand what the population is. Yes?
Are you going to be like super specific about it? Like, can I write just proportion of chips with blemishes? You have to put like the on truck.
I want the on the truck because we're talking about that being the population.
Oh,
It's how I'm going to know you understand we're talking about the truck. Okay. Then you need to state the significance level, which they give you right up there in the paragraph. Alpha is 0.1. And then lastly, you need to tell me what evidence we have so far. It's called some evidence for the alternative. I've got a little bit of evidence here that more than 8% of the potatoes on this truck have blemishes. That little bit of evidence comes from the sample. Check this out. I took a sample of 500, and it turns out that 47 of the 500 potatoes in the sample had blemishes. If you grab a calculator and you divide that out, you get something greater than 8%. You get like 9.4%. There is a little bit of evidence, there's some evidence that this is true. Because here it is. If it makes more sense for you to put it in percentages, you're always more than welcome to do that. Either or is good for me. But let me tell you what you just found, and some of you know this. You just found the proportion of potatoes in the sample that have blemishes. That means you just found p hat. So later on, when I have you list p hat, it's 0.094. Don't sit there and try and find it again, okay? That's the proportion of potatoes in the sample that had blemishes. Now, we are finished with the state part. Now we're going to do the plan step, which is checking to make sure conditions have been met. Those conditions are the random samples condition, the 10% condition, and the large counts condition. These are the same exact steps we're going to see in 9.5. Just a little bit different math stuff. Now, random means don't just check it. Tell me what up there in the paragraph lets me know that the sample of 500 potatoes was chosen at random. It says random sample, yeah. How easy is that to get some points? Check. The 10% rule says that the sample size has to be less than 10% of the population. So you have to understand that the sample of 500 potatoes, we're having to infer that that's going to be less than 10% of all potatoes on the truck. The reason that on the truck is important is if you just leave it at all potatoes, was that all potatoes in the world? Is that all potatoes in the US? Like, it's not specific enough. We're talking about potatoes on the truck. Now, the reason I know that is because there's going to be more than 5,000 potatoes on a giant truck. Okay? Now, large counts is where we have to do a little bit of math. We need to check that sample size times P null is greater than or equal to 10. And we need to check that n times 1 minus, a little p with a sub-zero, is greater than or equal to 10. Now, a lot of you know n is the sample size. Oh, that's the 500 potatoes. But you may have already forgotten where we're supposed to get this value from. Where does p null come from? And it's right up here where you have another null symbol. It's just whatever number is hanging out in your hypotheses. You're always just going to use that for P0. Every single time. That's what it is. So let's kind of show a little bit of work and then grab our calculators. So 500 potatoes in the sample times 0.08. 500 times 0.08 is 40. So that checks out. Over here, it's 500 times 1 minus 0.08, or there are some of you in here that are sharp enough to know that that's the same thing as 0.92. If 8% is over here, 92% is over here. But if that just blows your mind, that's okay. Just plug it into the formula that you have. That's 460. I don't know that I've ever pointed this out to you. What do 460 and 40 add up to be? 500, that sample size of 500, that's not a coincidence. That'll always happen. So maybe that's helpful. Maybe that lets you just jump to the, hey, this is going to work. If this is 40, this is 460. They're both larger than 10. We're done. We're moving on. So there's all kinds of shortcuts if you can make the connections. That's it on the plan part. That means we are allowed to proceed with our test. That means we are to the do step. Yes, if those don't check out, then you would just stop there. I'm going to tell you right now, unfortunately, that's never going to happen. I'm going to make sure that you have to go through all the steps. That's just my mean soul coming out, okay? Do. I want 3 things. I want you to make sure you tell me the statistic, which is p hat, which we already found up there in step 1. And then you need to tell me z. There's a formula for z, and it says this. P hat minus p null divided by the big square root of this fraction. And the fraction is p null times 1 minus that, all over the sample size n. We know all of that stuff. So yeah, you're filling up the page with writing, but each and every step, if you just take it one little step at a time, is not hard. So we know that p hat is 0.094. 9.4% of the sample potatoes were bad. Now what we're going to do is we're going to subtract the 8% that's hanging out in our hypotheses. We're just plugging in the stuff that we have. Over the square root of 8% times 92%. I don't want that to freak anybody out. You're more than welcome to put 1 minus 0.08. All over the 500 potatoes. Now, let's get our z value. You're going to get some points for doing, you're actually going to get 15 points on the quiz for finding z, the correct z value. So that's quite a bit of points. Make sure you can confidently put this thing in the calculator. We have a fraction, alpha y equals 0, alpha y equals enter. The bottom is a square root of another fraction. And the more you do this, the faster you're going to be able to zoom right through it. Always just kind of double check that you're good. And you should get this. You're more than welcome to round it. You can put 1.15. Always go at least 2 decimal spaces out to your hundredths. If you want to put 1.154 because you want to be more accurate, that's also fine. But always go at least 2 spaces out. There is the z value. Oh, 1.15. Excuse me. I don't know why the heck I put that. 1.5. Okay, thank you very much. That's important because the next part is going to build off of this. So if this isn't correct, then your p-value is wrong, then your conclusion is wrong, and everything just falls apart. No pressure, right? P-value. Here's what you're going to do. You're going to draw a picture. Yes, you have to draw a picture. What you're going to draw is a standard normal curve because you just found something called a standardized test statistic. It goes on a standard normal curve. Now when I say standard normal curve, all I mean is 0 is in the middle and you count by ones. Mu is 0, standard deviation is 1. Yes, if your picture is ugly, you're going to fail the quiz. No, I'm not going to judge you. Yeah, mine aren't very pretty either. You're fine. But draw this thing. Now, if you draw it like a pointy upside down V, I'm going to worry about you because these are smooth bell-shaped curves. Try your best. It's just like a little ghost. That's what it looks like to me. Label it. And then show me where Z falls on this curve. Draw a little vertical line where Z is. 1.15 is going to be a little bit to the right of 1. Now to this really critical step. We have to shade one way or the other. If we do that incorrectly, then we're going to find the wrong p-value, and again, our conclusion will be wrong. So look back up at your alternative hypothesis. Well, I went too far. Greater than. Shade to the, it's an arrow pointing that way, right? Shade to the right. And that's also on the first page of your notes, so I'm just going to kind of stripey that in. I don't care if you stripe it. I don't care if you shade it. I'm not that picky. And then to find the p-value, you're going to use normal CDF. Now, I don't care if you write normal CDF on the paper, but you might want to just jot a couple of things down so that I know if you got it wrong, where you went wrong. Maybe I can give you some partial credit. It's always best to just write everything you can. Look at your shaded region this time. What is the lower and what is the upper? Yeah, Z value happens to be the lower this time, and the upper is the 1,000. Okay, now grab your calculator, do this, and you will have found the p-value. That's what we're doing right now. Good. It's been possible the whole time, Dax. I promise. Second bars, yeah. Second bars, option 2. You just have to put lower and upper. Your calculator is already defaulted to the standardized distribution, standard normal. 0.13 or 0.125, whatever you prefer. It's helpful if you like circle or box in the things that need to stand out for me because then I can grade it quickly. Okay, we're already to the conclude part. So here's what you're going to do. You're going to tell me what we just found, the p-value of 0.13. What we're doing is we are comparing it to alpha. So I'm going to leave a little blank space because I don't know where my alligator mouth is going to face. But the alpha that was stated way up there in the paragraph is 0.10. When I say compare, I mean, well, which one is bigger? P-value is bigger. Alligator eats the bigger one, right? So the p-value is greater than alpha. And then you're going to go back here just to be really careful. You're going to find, oh, if the p-value is greater than alpha, here's what my sentence is going to say. There is not convincing evidence for HA, comma. Yes, sir. Yes. Fine. Taylor, Mr. Thompson in the counseling suite wants to see you. There is not convincing evidence which is great. Maybe I'll give you a couple of points if you can write that much. But I want it in context of the problem. So don't lose sight of what this whole problem is about. It's about the alternative hypothesis, which is there more than 8% of potatoes on the truck that are bad? Well, there's not convincing evidence of that. So we're going to finish out by writing that more than 8% of the potatoes on the truck have blemishes. That's what the alternative hypothesis is. There's not convincing evidence that more than 8% of potatoes in the shipment or on the truck are bad or have blemishes. That means that I would feel okay keeping this truck of potatoes, as long as I didn't make a type 1 or type 2 error. So that, ladies and gentlemen, is the 4-step process. We're going to pick up the pace when we turn the page.
Oh, no.
I want you to read through this, and I want you to circle, highlight, underline the stuff you think is important, that you know you're going to need. And then I want you to see if you can write the hypotheses, and then you can stop there. Just write your hypotheses and stop there so we can make sure you did that the correct way. There's a percentage in the problem. So it's a problem about proportions. That percentage shows up in the hypotheses. There's always an equal sign in the null. This one is not as obvious as example 1 as far as it doesn't say more than, less than. It says that this editor believes this figure is too high. In other words, 35%, he thinks that's too high. So he thinks the proportion of U.S. adults that have seen the show is, what do you think, greater than? Okay, less than 35%. So you have to infer a little bit. Sometimes, you guys, you're going to find that at the end of the paragraph. It might be in the middle. It might be at the beginning. So search around for your clue. Because once again, that symbol, that little bitty symbol right there, everything else is kind of built on that. Okay. Think about, if this was your quiz, what you would tell me P stands for, and write it down. proportion of blank. You're telling me that you understand what the population is. Is it teens? Is it adults? Is it all the adults in the world? Is it U.S. adults? Be specific. Yeah, U.S. adults. The proportion of U.S. adults who've watched this show, Survivor. Cool. Tell me the significance level. We are testing a claim at this significance level. And then lastly, tell me what little bit of evidence we have that this editor is correct, that there is less than 35% of U.S. adults who have watched the show. Now that some evidence always comes from the sample. Well, I asked 200 U.S. adults if they'd seen the show. 60 of those 200 adults said yes, they had. That's 0.3. Well, that's less than 0.35, so there's a little bit of evidence that the HA is true. Or if you prefer to see that with your eyes as 30%, that's fine too. Again, what you just found is the sample proportion who watched the show. That's p hat. Plan. See how fast you can move through this. I'm not going to say anything, but you can just check the screen when you're ready to kind of make sure your little bits and pieces match mine. Good, I hear you guys flipping back to that example one, kind of looking and seeing what we did. That's perfect. That's what you'll probably need to do on the quiz if you forget. Reference your notes. That's what notes are for. You know, in high school, sometimes we take notes and never look at them, but in college you will. Promise. Again, a little shortcut here is if you know that this one over here is 70 and they're going to add up to be the sample size of 200, that means the other one has to be 130. So it's okay if you don't show all of that work, as long as you show me that your two values are greater than or equal to 10. Is anybody still in the plan phase? Okay. If you are ready to move on, think about what 3 things you need to put in the do. Your statistic. Statistics come from samples. That's what that's called, is a statistic.
Can you flip the paper over a little? Yeah.
The z-value. I know some of you can just pick up a calculator and put all the stuff in and get the z correct, but show me just a little bit of work, like what you type into the calculator. At least tell me what you're plugging in. If you don't want to write the formula itself, that's fine, if that feels like it's busy work. But again, if you make a mistake and I can find where it is and it's one tiny little thing, maybe I can give you some credit, like give you some feedback so you don't do that on your project. There is value in showing work.
I'm confused, where'd you get 0.65?
1 minus 0.35 is 0.65. And Dax, the formula says 1 minus whatever is out here. So if you want to just put 1 minus 0.35 in there, that's the same thing. Your z value is negative 1.48. Show me that you understand what the z value is by drawing the picture. The picture will also tell me that you understand which way to shade. Which way are you going to shade on this problem? To the left, because your symbol is less than in your alternative hypothesis. Who cares which way you shade? Well, it's going to affect your lower and your upper. Or the shaded region. Now our lower is negative 1,000 and our upper is the z value. Second bars, normal CDF, lower, upper. Enter, 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 enter. You can put 0.07, 0.069, that's the p-value. Your conclusion is based on that. Does anybody have any questions so far? Conclude, and I've just got a little bit of space left. The p-value of 0.07 that I spent all that time finding, I'm going to compare it to alpha. And the alpha that they gave me was 0.05. So the p-value is greater than. There is not convincing evidence. For HA, and if you're confused, you're like, I've never really understood where she gets this next part. Think about it this way. Tell me about what the HA says. And if you go back up there, it says that less than 35% of US adults have watched the show. That's what HA says. That less than 35% of US adults have watched the show. This is very much how your project will feel. There's going to be a little extra stuff that you have to do. But the guts of the project is the 4-step process. Now there's one teeny tiny little thing that I need to tell you. There's a reason why there's a third example on here. I'll tell you when you get back from lunch. Macy, you never went to get your ticket.
I'm just gonna go get the money from our class.
All right, the only thing that's going to be different about the next example is it's called a two-sided test, okay? I have tried to stress the importance of being able to determine if your alternative hypothesis is one-sided or two-sided. The last two examples we've done have had either a less than or a greater than symbol. That's a one-sided alternative hypothesis. We shade either one way or the other, so it's called a one-sided test. The only difference between what we've done and example 3 is you're going to have to find the area in both tails. That's really easy. You'll just find the area in one tail. You can choose the left or the right, doesn't matter. And then just take what you get and don't forget to multiply by 2. That tiny little difference at the end, sometimes people forget. So just keep that in mind. Turn the page. Let's move through this quickly, please. Read this paragraph. Pretend this is your quiz question. Pretend this is your final project in your high school math class ever. And find the important information. Percent. Sample size. 29. Significance level. And I bet after just doing this 2 times before, you'll have a lot of this process already memorized. Try to avoid those silly mistakes. Bless you. Like 27.5%. Make sure that you don't get carried away and like put 0.0275 or something. That would change everything. Okay. So there's this national result that this percentage of all high school students have vaped, and this is from 2019. Anton just wonders if this is true for his high school. And if you'll read at the end, there are a couple of words that let you know what symbol you're supposed to use right here. He wants to know if the proportion of students at his school who have vaped differs from. So he doesn't know if it's more than 27.5% at his school or less than, but he's just testing to see if it's different than, differs from. Immediately, I'm going to make a couple of notes. That's what I'll use for P0, and this is two-sided, so I'm going to shade both tails. Those are just notes for me. And then there's actually a phrase right out of the paragraph that you can copy word for word that tells you what P is, and it's right here. It's the proportion of all students at his school who have vaped. Specifically students at his school, that's our population. It's not all U.S. teens or anything like that. Proportion, percentages. Significance level, 0.05. Some evidence that Anton has found that it is different at his school is hopefully this was anonymous so people were honest, but he asks 150 students, 29 of them say that they've vaped before. Now there might be some response bias in there, you never know, especially on a sensitive topic. There's a little bit of evidence right there because that's less than 27.5%. Or excuse me, not less than. It's different than 27.5%. He's got a little evidence. Now, that's P hat. Let's move on. Plan. I already told you that all of these are going to work, right? Let's kind of go a little bit faster through this because this lesson's already been kind of long. I will expect for you to do more than just check mark it. You must tell me in words or symbols or something that the random and 10% rules check out. When you get to here, I keep mentioning this shortcut. Let me show you. If you take the sample size and multiply by 0.275, you get 41.25, which is greater than or equal to 10. Well, whatever you're going to get over here, when I add it to 41.25, I'm going to get the sample size of 150 students. So the really fast way is just take 150, subtract 41.25. If you were to sit there and do this math for n times 1 minus p sub 0, you would get 108.75. If you feel like that's just one more extra thing that you have to memorize, then ignore it. But these will always add up to be the sample size. So I know that it meets the large counts condition. Do. P hat, that's your statistic. That's what we'll plug into the Z formula that's coming up right now. When you're working on your assignment, there's a problem where I messed up and I accidentally, the formula says P hat minus P null, and I accidentally flip-flopped them. Coincidentally, my answer ends up being almost correct, but it is just a coincidence, okay? So just be careful there. Don't make mistakes that I do. You'd be better than me. You don't have to have formulas memorized. You can tell you're going through this 4-step process a lot faster than you did earlier in this class today. So it doesn't have to be this painstakingly long process. Z can be positive or negative, so that don't freak out. Oh gosh, I got something negative. Is that allowed? Yes. You're just going to you're going to draw that on the standard normal curve. There are negative and positive values there. So negative 2.33. You can draw your little picture below. You can draw it off to the side. I mean, as far as the way you show me the information, it would be great if it was consistent and organized. Negative 2.33 is going to be like over here. Now typically here is where we say, okay, do I shade to the left or do I shade to the right? But because this is a two-sided test, because we have a not equal to, here's what we're going to do. We're going to shade this tail over here to the left. And then what I haven't told you in detail yet, and I think this is probably common sense for a lot of you, is we're going to take this Z of negative 2.33 and plot its absolute value. All that means is make it positive. And on the front page of your notes, it actually says absolute value. The bars are there, okay? But anyway, that's how you know that's where that lands. If you've drawn a semi-decent picture, you'll just kind of notice that those are the same exact area. So listen, you have choices. You can find this tail and double it. Or you can find this tail and double it. It does not matter. But just think about what you're doing. I don't know why, but I always just find the left one. And the more consistent you are, the less likely it is you're going to mess up. So if I always find the left tail, that's going to be my lower is negative 1,000, my upper is my z-value. I'm going to go ahead and do the whole normal CDF thing. And that's basically 0.01. But that is not the p-value. That is just the area of this tail over here. Double it. The p-value is 0.02. That right there that I highlighted is the only reason we've had to do example 3. Is to make sure you have at least seen it once in the notes. I'm going to tell you right now, your project is going to be a 2-sided. Just so you have that extra little step. Because again, I'm mean. And I enjoy being mean. Conclude. P-value of 0.02. Compare that to the alpha level of 0.05. I think it's pretty obvious that the p-value this time is smaller than the significance level. Therefore, looking back at my handy-dandy chart, boop, smaller than, there is convincing evidence for HA. What is that again? Reference it. That the proportion or percentage of students at his school who vape is different from the national result. Or you could put different from 27.5%. There is convincing evidence that the proportion of students at his school who have vaped is different from the national result, or 0.275. And that's it.